Sorry, can you say that again? Someone put what is their favorite movie in the midterm?
In my finance, one of my finance courses, it was like a third year course.
Yeah.
The tutor, well not tutor, the lecturer put in the midterm, what is my favorite movie? And he said in one of his lectures, I didn't watch the lectures, so I dropped the course.
I mean, fair enough. Like that's, there was like this Buckland thing where he would like, oh no, what he would do is he would lie about something in the lecture, and then he'd put the question in the exam to see whether you were actually paying attention. Which I don't know. I think that's funny, but putting that's just a dumb question. That's like, what are you paying for at this point? Anyway, does anyone else feel out my experience? I've got like 5 left. Really? I believe you. Good catch. I'm clearly not in athletics, as you can tell, otherwise I wouldn't be here in the Olympics. Cool. Is everyone finished? Or? You done it? Yeah.
So be the one to say.
That's all good. Just do it later. All right. This visitor pattern question is a bit. Well, let's just burn through it. We'll talk about the visitor pattern, and then we'll do the code because that's fun. Here we go. So I'm going to kind of preface this example by saying this is not a great example in terms of why you would want to use the visitor pattern, but it's more just to illustrate what is the visitor pattern, how do we apply it. So let's, again, I like this idea of like doing it first and then we'll talk about why. So let's get straight into it. We have some computers, keyboards and mouses. They're all of type computer component. There's some sort of inheritance relationship. We want to be able to visit different types of computer components by logging the following messages. Blah, 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 blah. Okay. If you're visiting a computer, you have to validate it. All right, interesting. So let's use the visitor pattern to do some stuff. The first thing we start with is our visitor interface. We're going to be adding several methods to this. But then what we're going to say is, this is like our visitable interface. So you could also call this visitable. We're just going to call it computer component because semantically that's more like relevant here. And you can see that our methods implement this interface. So what we're going to put in the interface is a method that says public void accept, what do we call it? Computer visitor. So you can kind of think of it like you have some sort of object, some sort of thing, usually it's like the data structure of some kind. In this case, it's our computer component. And then the visitor comes knocking and says, hello, I'm not here to huff and puff and blow your house down, but I want to visit you. I want to come in. Please let me in. And the object can say, visitor, and this is the object. The object can say, oh, yeah, maybe, or maybe not, or maybe there's some sort of logic. And there's not a lot of logic in this situation, but it kind of gives you an idea of how you structure it. So let's change all of our computer components so that we implement this method. All right, so let's start with the easy one. All that's going to happen here is there's no logic wrapping around this. So we're just going to say visitor.visit this. And we pass in the mouse itself as a parameter. And so now if we go to computer visitor, well, we need to actually add a visit method. So we'll say public void visit. And then we want to be able to visit a mouse specifically in this case. We'll say mouse, and then define this method. And now this will work here because we pass in an object of type mouse and we have a corresponding method in our visitor class. And now what do we want to do? We want to do perform some sort of operation, do some sort of functionality. I really like the Lab 10 calculator example where you're kind of traversing this. Are you doing it? That's right. You're traversing this like composite pattern, like the calculator we did in week 7, and you kind of have to work your way down the tree, and you're sort of visiting each level as you go, and then you can, visit the left node, visit the right node, and do that recursively until you get to the base. In this case, we're just going to say system.out.println. What are we? Looking at a mechanical, oh no, this is a keyboard. Looking at a mouse, and then the mouse will have some sort of name, I take it. Yeah. ToString. Yeah, sure, we'll just say toString. Looking at mouse, mouse. And that will just automatically toString it for us. So if we say mouse.accept visitor, and then let's run that. So it goes, okay, I'm going to call accept. Inside the accept method, we'll go to implementations, which is here. This is a cool trick you can do, by the way. You can like go to different implementations of methods. And then we say, okay, call the visit method, go to definition. That lives inside, that lives inside here. And then this just gets called. So you kind of think, you might initially think, I don't get the point of it, because you're just doing a whole bunch of method calls. This is called a double dispatch, where we say, okay, I'm going to accept this thing, and then that calls the visit. So then you get 2 essentially dispatches. And it's hard to see why here, but I'll explain it a bit more at the end. So now let's do the keyboard. Yeah. We're going to first start by, again, there's no logic surrounding this. We'll just say visitor.visit this. And then in the visitor, public visit and keyboard. And I think we do pretty much the same thing. We just need to say the number of keys. Keyboard.get num keys. And we need this one, I think, plus keyboard.toString. Yep. And then similarly, we'll say keyboard.accept visitor. Oh, that does its thing. I don't know where to put this. And then lastly, the computer. That's slightly more interesting, because we have to have this idea that the computer must be, sorry, anyone visiting a computer must be validated. So if we look at our computer component, our computer itself, there's nothing special here. So we're going to need to say, well, is this thing validated? I don't know what that means. Don't really care. We'll say private boolean validated equals false. And then inside computer, we'll say, given this visitor, if visitor.validated, then let's do the actual visitation. This doesn't exist, so let's make it. Just going to go right click, source action, getters and setters. Oh, is validated, sorry. Cool, and now we need to actually define the visitation here. So say public void visit. And then same thing. So we'll look at this computer, which I think is just a toString, and the memory is computer.getMemory. And then we'll say computer.accept visitor. Now this isn't going to work because we haven't actually validated it yet. And you'll see that we run this and nothing prints out. So let's then do the same thing and say visitor.get set validated true, and then do the same thing again. Done. That's it. That's the visitor pattern. Now, you think that's kind of cool? We've got this double dispatch thing going on. Why would we ever want to use this pattern? Does anyone know?
Like two for validation and like visualization stuff. So it's like for example, if you've got an API and you've got user types, then you probably don't want to set the users to use certain endpoints.
Yep.
So you can very easily just call the user visit pattern to say that this user is visiting this API. Do they have without permission? So then go the call.
Yeah, I like that one. I think it kind of speaks to this idea that, like, someone in the forum asked me about, we had a discussion about whether something was a visitor pattern, and initially I said no, and then I said yes, because it kind of comes down to this idea where you're separating. I kind of just wrote it off. You have an object, and then you have some sort of algorithm, and you want to implement some sort of layer of separation between the two, whether it's because you need an authorization layer to say, well, can the user actually perform this functionality? You know, can we do the whatever crap on the keyboard? Or whether you want to say, well, it'll depend on what the object is and what the algorithm is. So I think a good example is like in your project, when something steps onto a square, you know, like that will be different between, when the player steps onto a square. I think this is what the example in the forum was. You know, it'll depend whether, like, if this is a collectible, then a certain thing will happen. If this is an enemy, then a certain thing will happen. If this is a boulder, then a certain thing will happen. And so you can kind of do this double dispatch to, I think my impression of how they did it was like you can do stuff on both sides where you do the visitation and the accepting, which enables you to manipulate both, you know, the thing that's being visited and the visitor itself. In a lot of cases, you just want to separate object from algorithm. The other thing it's really good for is, and this is the case for lab 10, is where you have, let's say you have this big legacy system. Kind of gets what we were talking about last week. You know, here's this big system, and you're like, I don't want to change a bunch of stuff, but I want to add some functionality. You think, oh, God, this is really annoying. You know, maybe it's badly written, or it was written a long time ago, or it was something you don't have to go and change everything and refactor everything and start from scratch and blah, blah, blah. So instead, what we can do is kind of build these hooks into the system like this. This is kind of different from like a template pattern book that we talked about last week. This is more of just an idea where your system has these almost like USB ports, right? And you can plug something into the port, or you can latch onto the hook and say, this algorithm is going to do this thing on this hook, this thing on this hook, this thing on this hook. And you can define different behaviors like we have here, these different visitation methods. And the idea being is like, all you have to do is, you know, put on the hook, and then your visitor actually has functionality, and you've separated the two from one another. And you don't have to go back and change a whole lot of stuff. And in that way, your software is open for extension and closed for modification. Yep. The thing is that something's a bit off about that, though. What's kind of off about that? Someone else? We talked about last week when we were talking about, you know, this idea of like you have a code smell and you fix the smell, but you didn't actually fix the problem, you just fixed the smell. Could we see something similar going on here? Because what would you, I mean, maybe the visitor pattern is fine, but what would you ideally like to be able to do if you want to add new functionality? You just add it in, right? It's like milestone 3, go build this. You're like, okay, cool. We're going to change our system. Maybe do a bit of refactoring, a bit of tinkering, open stuff up. And maybe your software isn't completely open for extension, but it's well designed enough, it's robust enough so that you can come in and change stuff, change the requirements without everything breaking. If you're having to use a visitor pattern to say, no, I actually can't touch anything, all I can do is put these little hooks onto the system and have everything done externally, then that might be a sign that you have bad design going on. So in that sense, sometimes I think about the visitor pattern as this, you know, like it's just a workaround for not actually fixing your design, but I don't know, sometimes it seems pretty good. Cool, 634. Let's do the Kahoot. I'm just going to pause the share for a second because I forgot to bring it up. Where is it? I can't find it. All right. Sign up, login. Is this me? No. Right, here we go. Get out your laptops, everyone's favorite time term. Time for the Kahoot. Here is our noise. No. I don't know why the things. Oh, look. Oh, we have just enough chocolates for 3 people to like the podium winners to get an extra chocolate. All right, anyone still going? Or can we start? Okay, we good now? Cool, let's start. Yeah, Java doesn't have structs. Like I know we talked about data classes as structs, but they're not actually structs. They're just classes. Like you can think of them as structs. Not access modifiers. Glad no one said automatic memory management. I'm very sad. Okay, cool. Let's just like burn through these ones so we can get some big ones. Well done. I'm very surprised if the team got that wrong. Oh, true or false? James. Actually, the correct answer is sort of all of them. I don't know what dynamic paradigm is, but you know, it's like the Java implements functional paradigm. You can do procedural programming in Java. I saw it in a few people's assignments where the program looked like a big pyramid. But yeah, it's the object-oriented programming language. Are we all right? It's only a game, guys. It's only a Benjamin risen to the top. It doesn't implement constructors, right? We need to define your own constructor. Wow. Yeah, so it's protected then default. I think, yeah, you just got those two mixed up. None of these questions we were put in an exam, by the way. These are just a bit of fun. Some of the later questions we will thought we could. It's false because why? Yeah, you didn't give in the right constructor arguments. Good job. So that way too much. Actually that wasn't the exam. Good stuff. I'm so glad that was the fastest question. I'm very, if you've got nothing else out of this course, then that good question. Low coupling, high cohesion. No. I would expand it, but then you can't see the possible answers. Oh, this one's interesting. Really early on, I think. This, maybe I did it with the other class, the Friday one. But how constructors work is that it initializes, we've got an object type third here, and it goes all the way up the class hierarchy and says, okay, we're going to initialize the first, then we initialize the second, and then we initialize the third. Then we talk about the different areas of memory and stuff, where it's like, you have part of your memory that's the first bit, part of the second bit, that actually gets initialized in as well. Not like core content. We've kind of moved on from how Java works, but it's just kind of interesting, I think. All know this one. Well done. Whoever said it was polymorphism, shame on you. Cool. Good stuff. Yeah, no, it's method overreacting. What are you guys talking about? Cool. Method overloading. Easy. We did this last week. Non-abstract methods as well as abstract methods. That's how the template pattern works, where you have some steps that are defined in the abstract class, but some aren't. Yeah. Dave's come up. James is still on top. Meter, or the principle of least knowledge. All subtypes must be substitutable for their base types. If you're a square and all squares are rectangles, then you have to be able to say a square is a rectangle and it still behaves like a rectangle. In this case, it doesn't. Why are you guys swooshing people? Right. Glad no one said the state pattern. I would actually argue you could say strategy pattern. It's like, what functionality is there, right? Because you could just have, it could be, you know, red, orange, green. And if it's all like, because the other thing is you can go, the answer is actually strategy. So you're wrong. It's a one person. Because you can, oh no, you can't, sorry. My brain's not working. Because you can't go from, you can go from red to green. You can't go from red to yellow. That's not a strategy pattern. Yeah, never mind. I don't know. There's some strategy like behaviors, I guess. This one's a bit of a gray area. Oh, it's one of those ones where it's like a detects if you're at the line and then just changes. I guess so. That's all the question said.
No, I didn't do that.
Yeah. Multi-select. That made a strange noise. I hope you all appreciated the orange one. Dave's climbing. Good job. So this one is like, the thing about patterns, right? Like we talked about, you know, exceptions and generics and all this stuff, which you like, it's not that you have to use them, it's just you do use them. So you use all these patterns, you know, if statements, for loops, they're all just patterns. What this is trying to say is, you know, it's like what we talked about in week 7, where you shouldn't go looking for design patterns under a rock. Like the whole thing of, you know, you need 4 design patterns. There's not a thing in real software because the problems just lend themselves towards design patterns. And, you know, as I said before, it's like you've got these tools in your toolkit and you need the right tool for the right job. Cool. J and Y cookie climbing. Oh, that's fine. That's a good question. Can you imagine for the project if every time someone made a question on the forum, we would go, oh, I didn't think of that. Let's update the spec. 50 billion spec updates a day. So instead we just say, oh, it's undefined, right? And that's all designed by contract where it's not in the scope of the specification, then the behavior is undefined. So it results in more simple code because you don't have to deal with certain conditions on whatever front, whether that's, and this is just like a general thing. it's like designed by contract from us in the project, designed by contract from you, and like, what could the user possibly do? Well, this behavior is undefined, so it doesn't matter. Right. So this one's interesting. This is like saying, like, you buy an airport ticket, and then they say, you buy an airport ticket, and you're like, and then you rock up, and they go, oh, no, actually, we changed it last minute so that you have to bring your pet with you on the plane. And you go, what? That's not what I signed up for. Yeah, well, that's the rules now. We changed the rules. So what they've done is they've strengthened the preconditions, right? Where they've said, not only do you have to have your ticket, but you also have to bring a pet on board with you. And you go, well, I can't do that. And I signed up thinking that I just had to bring a ticket. I don't want to bring a freaking pet with me. And it's the same thing in LSP, where if you create a subclass, right, you can't treat it as the base class anymore if you strengthen the preconditions, because that's not what the base class signed up for. Does that make sense? This is probably one of my favorite questions for the exam, just generally, because it's like designed by contract and LSP. There's one in the sample exam, which was in last terms, or maybe the last year's exam, I think the term 2 exam, which is just like this question basically. And once you understand the ideas of design by contract and just like try to think about it in real terms, rather than just like preconditions, postconditions, all that stuff, then hopefully it makes a bit of sense. Oh, it's got both. It's the same thing again. This is the other side. Now it's like you bought your ticket for the plane, and then they go, oh, sorry, the in-flight meal service is cancelled because of COVID. You're like, I didn't pay all this money and not get fed. No, it's the same idea where you as the, if you're expecting the base class type, then you can't have the subclass suddenly say, no, I'm actually going to not do that bit, or I'm going to change the post conditions in some way, because then the behavior is not consistent and you break LSP. So yeah, not valid inheritance. Compile problems are not exceptions. The exceptions are all dynamic. Who's Derek? So it's not blue. This is, I think I briefly mentioned it when we talked about generics, but basically, I don't know if Java does this, C++ definitely does. If you define like your generic stack, your stack E, I don't know whether Java does this, but here's your generic stack. And then you say, okay, I'm going to make a stack of strings and then a stack of ints. What the compiler will do is this thing called static polymorphism, where in memory, it will actually say, okay, I'm now going to define a stack and I'm going to sub out E with string. I'm sure Java does this as well. And then I'm going to have another bit of memory. This is the definition for a stack of integers. And these are two different pieces of code, right? Like normally you have a function, if you think back to like 1521 land. Here's your function, and that's it. The function lives in memory. Now we've actually got different sort of template definitions for a stack based on what the generic parameter is. And like we could have a stack of strings or a stack of whatever, but it's only going to be compiled if you actually instantiate it. So that's why it's not blue, because it does actually get figured out at compile time, I think. And then the other two are true. So yeah, the methods define a generic class, methods that introduce their own type parameters. I guess you could also say that a generic method and a generic, no, actually that's the right one, never mind. False. So the inheritance doesn't extend to the generic parameter. Good job, iterators. Yep. Decorated pattern. Last week. Oh, this one's interesting. So, all right, what's feature envy? Yeah, sure. Not necessarily another method, but yeah, you're on the right track with that. Here's like what I think all of you had in your assignments. Let me get back to here. Something like this. File info response equals file, or like, you know, file.get ID, file.get bytes, file.get has transfer completed. What's the code smell here? File this, file that, file that, file it. It's like, well, maybe you should get the file to do it itself, right? So this code smell is saying, you know, I'm so envious, this class is so envious of the files feature, is that we, you know, maybe we should think about delegating that functionality. Cool. All right, message chains. What about that one? Sorry? Yeah, kind of. Anyone else? Yeah, it's like you're doing this kind of pass the parcel thing where you're like, I'm going to give this piece of this message to this method, then to this method, and this method. It's kind of like the law of Demeter. I mean, the whole thing is just about coupling, right? Yeah, and you've got this message passing along a chain. All right, what about this one? Inappropriate intimacy. So what happens when two classes get a bit frisky with one another? Yeah, it's essentially that, when it's just like, you know, there's kind of feature envy on both sides where, you know, one class is going to sort of overly reaching to another, and then another class is overly reaching. Like Java kind of prevents most of this with private modifiers. You have some languages like C++, I think, where there's like, oh, you have these like friend methods, and the friends, this like joke that like the friends can access the private parts of other classes, and it's funny. I don't know. Yeah, this one is just mainly, there's too much coupling between two classes. And then the last one is about inheritance, where divergent change. Has anyone, I was talking about this with my friends the other day, talking about like dystopian, like science fiction films and stuff. And has anyone seen the movie Divergent? Read the book? Yeah. Sorry. What's it about? Yeah, there's like factions. Yeah, that's got nothing to do. I don't know why I asked you that. I just thought, it's like the main character's divergent, right? It's that they, go off on a different track. So in inheritance, you've got your superclass, and then you've got a whole bunch of other classes. 1, 2, 3, 4, 5. And then maybe number 6 here is like, what's her name in the movie? Triss. Yeah, I thought it was Trey or something. So you got Triss over here who goes, well, I implement all the methods that you told me to in the superclass, but actually I'm going to do something that's not what the superclass told me to do, right? So it's divergent in that sense. What does that do from an inheritance point of view? Starts with an L, breaks LSP often. Great for a teen drama series, but not great for inheritance. That's divergent change. There's another inheritance code smell called refused bequest, which is, I think I was talking to one group about it the other week. Does anyone know what that one is? So again, we've got this inheritance structure, and the superclass says, I want you to do this method, right? I want you to implement this method. And you as a subclass go, oh, nah, I'm good, thanks. So a bequest is like, you can get bequeathed. Sorry, I was thinking about fantasy fiction and stuff where it's like you can get like bequeathed a certain quest or bequeathed a certain item. So the superclass bequeaths this method to the subclass, and the subclass goes, no thanks, it refuses it because it's not relevant. And it's like, oh, well, animals have legs, a chair has legs, therefore a chair can do a bark. And it's like, well, chairs can't make a noise, right? Chairs can't make noise. Something like that. So that's some code smells. Oh, it is. Right, who's the real James? Really? Yeah, you did chocolate. Good job. All right. Okay. Oh, you've already got that. You want another one? Who wants the last chocolate? Cool. We are at 7:06. We're going to